Alright, let's look at the practice exam 3, problem number 12, part B. Alright, so remember that by applying Stokes' theorems twice, we know that we can actually have a different surface as long as it has the same boundary curve. Alright, so in this case, originally it was a sphere with radius 3, but we can turn it into just a flat disk with the same radius, right? So we have this double integral here, right? So we still have to find the curl of f. So let's go ahead and find that. So we want to find the curl of f, right? Which is going to be, right? So we have vector I, vector j, and we have a vector k. Right, partial with respect to x, partial with respect to y, about partial with respect to z. Alright, then first component is y cosine of z. And you have e to the x sine of z. Then you have x e to the y, right? So this is going to be equal to, right? So first component, so you have a partial of x e to the y with respect to y would be still x e to the y minus partial of this guy with respect to z. So you have e to the x, and derivative of sine would be cosine of z, right? So the second component would be a partial of y cosine of z with respect to z would be negative y sine of z minus partial of x e to the y with respect to x. So you have e to the y, right? And the last component would be partial of e to the x sine of z with respect to x will be the same thing, e to the x sine of z minus partial of y cosine of z with respect to y would be a cosine of z. Alright, but the good thing about this is since this disk is on the xy plane, so z value is always equal to 0. So if you plug in z equal to 0, this curl is going to be a lot simpler, right? So in this case, z is equal to 0 here, so you have x e to the y minus, right? So z cosine of 0 is 1, so you have e to the x, right? And the mid component is sine of 0 is 0, so you're just going to get the negative e to the y. And the last component is, let's see, sine of z is 0, and the cosine of 0 is 1, so it's going to be negative 1. Alright, so you're going to have x e to the y minus e to the x, and you have a negative e to the y, and you have a negative 1. Alright, so then you want to find the unit normal vector. So normal vector is going to be simply a k vector, so it's going to be 0, 0, 1. Alright, so this is going to give us, right, so if you multiply out, so this times 0 is 0, plus that times 0 is 0, only thing you get is negative 1. So you have a double integral over d, so this is a disk with radius 3, and a negative 1. So I'll actually put the negative sign outside, and then you have a dA. Right, so you can see that this is going to be negative, and double integral over the disk d, dA is just going to be area of the disk d, right? And so it's a negative. Area of D is very easy because this is a disk with radius 3. So area is pi radius, which is 3, squared. So you can see that you're going to get the negative 9 pi. Right? So we got that. Right? As you can see that we get exactly the same answer as part A because we are evaluating the same surface integral. Right? That's it. I hope that this was clear.